Hey everyone, in this video I'm going to go over file links. I'm going to start with symbolic links. Symbolic links are really just aliased paths or shortcuts to another file or directory. For example, we have the bin directory. And this actually points at USR bin. We have this cyan color here, indicates that it is a soft link. If we were to look through the file system on a clean install, we'd see other examples of symbolic links pointing in various places. And sometimes the purpose of this is because of something that changes as they advance the operating system. It might be something that older applications can look at while things are being completely updated to keep them from breaking so they continue to work. And sometimes you'll see this with applications. For whatever reason, they will look at they will place a link to certain directories in order to perform operations within the app. Another reason I can think of as a user, you may want to do this is maybe there's somewhere from your home directory where you don't want to type the full path all the time. So you can just basically create a shortcut right there so you can work from your home directory. So let's get started here and create a symbolic link. And the command for that is ln. And then by default, it actually creates a hard link. And we'll talk about that later. For a symbolic link, we need to use the S flag. And then we want to enter the directory that we want to link to, or the file. In this case, it will be a directory. And then the name of the link. Now, if we take a look here with tree, we can see that we have a link in this directory that points to A. And if we take a look with the stat command, we can see that they are different. So here it calls it out as a symbolic link. We can see the size is 8. And if we actually take a look at A, it's called out as a directory, and we can see that it has a different size here. But one more thing real quick here too is this is an absolute path to A with the link. And if we take a look at how this is linked, it actually points to the absolute path of A. So we have absolute links and relative links being relative to where you are in the system. Absolute links point directly to the item. So we could go ahead and move this link to our home directory here and change into our home directory. Now we're home. We could create a file within our link. And it still points to the same place. So we have no issues with moving around a link that has an absolute path. If it had a relative path, it would break the link. So I'm going to go ahead and move our link back. Go ahead and move back into links here. Let's go ahead and get rid of our last file here. All right, and just to demonstrate what we've already seen, they lead to the same place. And there's everything we created so far. And as you can see, either way we access it, whether we actually use the link or if we use the actual path, it is all the same place. All right, and so we can also link to a file. So this applies to more than just directories. Right to that file. But we will cat through the actual path to the file. And let's do a little setup here for our next example. Some directories. and create some files within there. There we have our 10 of our files. And we're going to go ahead and create a link to that directory. And we're going to go ahead and remove that recursively. And go ahead and check actual path here. And we still have all of our files here. So the point here is that there is different behavior depending on the flags that you pass to your commands. If you're dealing with commands that might recursively delete or copy files, and it might have a flag for the way it treats symbolic links and that dereferencing behavior, because all a symbolic link really is a reference to the file or directory that it's pointing at. So that's always good to check the man page to verify the default behavior of the command and how it treats links. So now we'll take another quick look at an example here of how that works with a copy. So let's just remake a, let's create some files here. There's our copy. And here we can see that we just have a copy of the link. So we have another file basically pointing at the same thing. So if we actually take into account that we're working with links and copy, and we use the L flag for dereferencing behavior, go ahead and copy link to A. We can see that we get an actual copy of everything that was within A there. Let's just do a quick demonstration of permissions here. So for example, if we give the others users right on link to A, see that actually applies to A itself because the permissions on a soft link actually show up like this. It shows up that it's a link, and then you actually see read, write, execute all the way across. So when you apply them to the link, it actually directs to the whatever it's pointing at. And if you don't have permissions to make the changes, it won't actually make the change. Let's take a look at what happens when you break a link. I've recreated our links here. So we have a link pointing to A. So if we removed A, you can see that it's now red, and that indicates that we have a broken link. You can also restore a link if you recreate the item that it points at. And now our link is restored. So one last thing we have with links are hard links. Hard links are different names that point at the same data. So let's just take a look here real quick. So if we have file, if we make a hard link, we do a long listing and list out inodes. You can see that we have the same number here, which means these are the same inode. Inode is a reference to where the data is at in the file system. We'll just kind of leave it at that, kind of keep it really simple. There's more to it than that. But for now, just to understand that if we delete the original file, we still have the same data. If we make changes to either of these files, it will make changes. So it's two different names pointing at the same data. You can delete one and your data will still be intact, whereas with soft links, if you delete the item that it's pointing at, it will delete the original data and you'll have a broken link. If you delete the link, you're just deleting the link. So that's the difference there. And that pretty much covers links. So if you found this video helpful and you enjoyed it, please leave a like and subscribe to the channel. And leave a comment and let me know what other types of Linux topics you'd like me to cover. Thanks for watching.